Okay. Good afternoon, everybody. My name is Ashkan. I'm from the University of Auckland. On behalf of the other authors, I'm presenting this paper. The paper is about using hybrid modeling framework for construction simulation. This is the outline that we're going to discuss about it, about the background, problem statement, research aim of this paper, a bit because some part of the paper is based on the literature review, so we have done some literature review to understand different of the simulation approaches, and the rest is a proposed framework case study that we have, and then challenges that in this type of hybrid model has, and at the end, summary. Okay, when we discuss about the construction projects are complex and dynamic system. What do you mean complex? I put some example why we say that complex, because different stakeholders involved, and why we say that dynamic, because of internal and external uncertainty that exists in the construction project. For example, finance-related uncertainty, a company financial capability and policy can change, while and about the organization-related uncertainty, different project states require different skill, different contributors and resources, and project participants vary through the construction process. And the last one, social uncertainties. The public can have a significant influence of the project outcomes. For example, resistance from the community can for the use of the overseas construction workers can have many effect of the project outcome. I show you some comments of the problems that usually we have in the construction supply chain in different parts. For example, between the owners and design, because of the wishes of the owner always change. So the one problem is that always the design issue should be changed and updated. And the other one for the purchasing and preparation, because of the inaccurate documents, we do some purchasing and then we should repeat it again because of the, for example, design changes. And also between the subcontractor and construction side, work not delivered according to the schedule that's approved or the contract, and also the main design. This is some common problems that you can see in the construction projects. And because of the problem that I mentioned in the previous slide, we use a simulation model as a decision-making supporting tools to overcome some difficulties that usually we have in construction projects. First, evaluate management decision about problems without the need to interface with the actual operations. Second one, experiment different scenario in a virtual environment that help provide us outcome by understanding the system behavior. In construction, the common simulation modeling is and preferred simulation modeling is the discrete event simulations, and apply in different construction settings. For example, planning improvement, analysis productivity, and also analyzing the environmental factors such as CO2. Although the discrete event apply in construction simulation, but it's still limited to the academic research, and construction practitioners are not interested in using the simulation techniques, discrete simulation approach. And I put some reason why they are not interested in discrete event simulation, because discrete event simulation cannot model the free movement of entities, cannot present the decision patterns of individual entities at the very small time increments, and also cannot model the emergent behavior that arises from the agent interaction at micro levels, and also cannot provide a holistic view of a system that can be modeled. So because of this limitation, researchers try to find solution and overcome to these weaknesses. So try to integrate the discrete with other simulation approaches like system dynamic and agent-based. Why we choose agent-based? Because agent-based look at the entity of the system as autonomous and intelligent agents can interact with each other and also with the environment to achieve the multiple targets. The aim of the research is a test of hypothesis that hybrid modeling, this type of hybrid modeling can improve the use of simulation in construction and also can give a better understanding the whole project of the construction project to the construction practitioners and overcome many limitations when you use the agent-based and discrete event in using in isolations. So because this paper somehow part of this paper to understand the strength and weaknesses of the discrete and agent-based, we've done a literature review about both simulation models. As you can see, discrete event is capable of capturing some level of the detailed characteristics of this construction system, not very detailed. And the most common simulation discrete event strategy that's used in construction is activity scanning, in which system focus on the activity that highly dependent on the time schedule and preconditions. Another two types of the discrete event strategy that are used in construction, also three-phase and three-stage strategy, somehow is a modified version of the AC. Simulation, discrete event tools, some researchers try to develop discrete event approach just strictly for the construction, that I put some of them, Cyclone, Cypros, Stroboscope, and Symphony. And in most discrete event commercial tools that use it for the construction apply a process-oriented approach. The weaknesses of this approach is that entity in this approach are not classified as an individual with own characteristic. Somehow they are not intelligent and just are data container. And also, as you can see, discrete event used in different construction contexts. We have a lot of paper that try to use in using discrete event in tunneling projects, also paving operation and earth moving. And the second one, that agent-based, is a bottom approach. Look at the system from bottom to up, and in this agent-based entity or objects are intelligent and autonomous agents that can interact with each other and also to the environment. And the agent-based has the capability to show the behavior of the individual entities and also the emergent behavior that comes from the macro decisions. There is no specific definition for characteristics of the agents, but some agreement that when talking about the agent-based models, the agents are autonomous. They can learn and they can understand and they can cooperate with each other. And the main point is that they're following if-then rule. The difficulties of the also agent-based using in different domains of the construction projects, safety and risk, bidding environment, resource allocations. Difficulty of the agent-based because of the needs, the heavy use of programming language like Java. So most of the construction practitioners are not interested in programming, so they don't interested in this one. And also validating agent-based models when at a macro level, when there is not enough correct empirical data, is very hard because the emergent behavior at the macro level is not related directly related to the individual agent's characteristics. So based on this, we try to understand first problems in construction projects, and then how the simulation models used to show these problems in construction. So based on this, we have we have done some literature review, and then changed this literature review to systematic literature review to exactly understand the strengths and weaknesses of each simulation modeling, and to understand the gap between the simulation modeling and problems in construction. Based on this, we developed a hybrid model framework, and then evaluate the framework based on the case study in New Zealand. After the modifying, develop the final version. This is a proposed hybrid framework. The first step to develop a hybrid discrete agent-based model is to provide answer the trick question: what are the problems are going to be answered, and what kind of information exchanged between the discrete and agent-based, and how these two types of simulation approach interact to each other. After identification of the problems and its attribute, continue including the scope, constraint, and also assumption, the objective of the models defined. And based on the objective of the model, we divided the system into the subsystem and processes, which is called modularization process. We adopted from the software engineering concept. And when we divided the system into different modules, for each module we use a criteria list to understand which simulation approach is appropriate with that model. So based on that one, we define for, and this is the, this is the criteria list that we use it for each model to understand for each model which simulation model is appropriate. Criteria including purpose, randomness, problem scope level, level of resolutions, system view, complexity, environmental actions, and control panel system process. And the method selection will lead to the following scenario. All models require simulation, one type of simulation modeling or different type. If they have a different type, is there any interaction between them or not? And after that, we need to identify a hybrid model. Why we needed to identify a hybrid model? To understand that because the hybrid model helps us to understand the interaction points and what information exchange. Actually, Charles provided three types of hybrid form: hierarchical form, process environmental form, integrated form. That based on each of them, that we don't have time to explain each of them, we can understand what is the interaction point and how the information exchange. And the interaction points, we have two types of interaction point. Output of one model is used as input of the other models, and output of one model influence the input of the other models. But we have a third type, that output of the one model divided, the value of output of one model divided or sum and used for the input of the other models. This is a case study. What you use is a pipe jacking project as a part of the city rail link in Auckland. The main challenge of this project is always behind the schedule. So objective minimizing total executive time and improving the efficiency. So for this paper, we just focus on the some part of the project. So we divided into two modules: production modules and logistic. Production modules including TBM, and logistic modules that look at the traveling the market scale. We use, because MTBM have a different failure modes, and the failure mode have different severity levels that cause from small to full replacement. And so we decided to use the agent base for the MTBM, and also for the Makiscape, discrete event simulation is used. This is the model that we developed, the agent-based model that shows the MTBM behavior and characteristics, and discrete models of the Makiscape. And actually, discrete event model is used as a supportive tool to enable. Okay, just one minute. Okay, a supportive tool to enable the MTBM behavior to be controlled. So when the Makiscape is full and stop exaggeration message sent from the discrete event to the MTBM agent-based models, and MTBM started to stop to working. And also when when the models, the Makiscape come back to the initial position, again the status of the MTBM changed from inactive to operation status. And the soil amount that are produced from when the MTBM is under execution status, put as an entity for the discrete event simulation. So this is a challenge, opposite of the discrete and SD hybrid models that they have a technical challenges. This type of hybrid, they don't have a technical challenges. The main difference is that entity of the discrete are managed through system level rules, but agent in ABS follow the rules that actually result from the agent and agent environment interactions. So summary of this study, we just showed the necessity of using hybrid simulation and also simulation approach to the when we look at the construction projects, and also we develop a hybrid framework that led us to overcome the limitation of agentless and discrete. And just this is the initial step of a continuous effort to develop hybrid modeling framework. Thank you. Sorry for the time.
Thank you very much for the contribution. We just have